the sum of 30 plus 6.
Okay, Mason?
The sum of 9 times 4 plus the sum of 9 times 3.
The product, that's okay, the product of 9 times 4.
Plus the product of 9 times 3.
Okay, hold on, I think I got you. So the product of 9 times 3 is what you said here? And then plus the product of 9 times 4. Okay. Sam?
36 plus 47
Remember, we're not gonna, well, we can talk about them here in a second, okay? Brian?
The sum of 30 and 20 plus 7 plus 6.
Okay. Ellie?
Okay. The sum of 20 plus 40. Wait, I messed up. The sum of.
Okay, we'll come back to it. If you think of it, we'll come back to it. Caitlin?
The sum of 27 plus 26.
Elizabeth?
The sum of 30 is 20 plus 7, 6. Oh.
That's okay. I thought that's what you were gonna say. That's okay, that's here. Jordan?
The sum of 17 plus 13 plus the sum of 10 and 23.
Okay, I'm gonna pause there for a second, because we're getting a little bit off track of our learning goal success criteria, because I tried to match this up with what we're doing in class. I wanna focus on all my addition problems here. So let's first start with this one. What property would we call this, class? Community. We just switched it up. Here, do we really need to put parentheses? You don't have to, how many terms do we have? We only have 2 terms. So we know what we're gonna do first, right? We're gonna add those 2 terms. So we talked about these 2. Community property, yeah, it looks different, but we're really not writing an equivalent expression. It's pretty much the same. So we know that's commutative. Let's look at these addition problems. Who did this one again? Who gave me this one? 20 plus 7. Justice, was this you? What did he do here? Grant?
He added more.
Yeah, we started with 2 terms. What's the point of writing equivalent expressions?
Make it simple.
Make it simpler. Now, does this maybe make it a little bit easier to add in your head? Yeah. He found a multiple of 10. What did he do to 27? Do you remember what we called this? You learned this in elementary. That's the standard form. This is the Ethan.
Expanded form.
So he did the expanded form. Is it easier to simplify by adding 20 and 30 to get 50? 20 and 30 to get 50, and then 7 and 6, the 7 and 6 to get 13 to get our. Are we trying to simplify it though? Does it ask us to simplify? No. This would be great if it said simplify it. We're not really trying to simplify it. We want to, like Grant said, we're trying to stick with the same amount of terms. Great equivalent expression, I would accept it, I like it, but it's not going towards what we're trying to do with our distributed property. And who did this one? I like how you grouped Brian, so she grouped for her multiples of 10 together, and then did her single digit ones. Jordan was being fancy here and trying to find other add-ins. Remember, we also want to try and keep the same terms. Okay, we want to try and keep the same terms. So let's now look at the one property we haven't talked about yet, our distributed property that we were working on yesterday. How is this the distributed property? Levy?
Turn into another expression.
Okay, what can I turn it into?
Like, 9 times 3 plus
So 9 times the sum of 3 and 4. This is what I was looking for with the distributive property. Okay? What did we factor out? What's the common factor? And what's the common factor here?
I don't know.
Not sure? Well, look at our, let's go back a second. How many terms? How many terms are here again, class?
2.
How many terms are here?
2.
How many terms are here?
3. 2. 1.
What do you think? Sam, you said 3. What do you think? 2? Because that equals 1 term, and that equals 1 term. So, what's the common factor, Maddie, that you see in each of the terms?
9.
9. Yep. So 9 is the common factor. Is it the greatest common factor? Is it the greatest common factor?
Yes.
Yeah. Is there another common factor?
Yes.
What's another common factor? What's another common factor? On your homework, I asked for the greatest common factor. For test questions, TCAP questions, they might not even ask for the greatest common factor. You just might find a common factor. Melanie, what's a common factor? 3. So who can give me an equivalent expression using the common factor of 3? We didn't find the greatest one, that's okay. Grant?
3 in parentheses 9 plus 9 plus 12.
How can I say this without saying it in parentheses?
Well, 3.
And then what operation are you gonna do? 3 times the, yep, 3 times the sum of 9 and 12. Who can write it to me another way? Show me another way with this. How else could I write this? What's your question?
Would we do like 3 terms? Like,
Remember, we want to try and stick to 2 terms. We don't want to make more terms.
no, but I'm just asking, would this work if we extended the last parenthesis and made it 3 times the sum of 9 plus 12, 6 plus 6. Or 9, yeah. Or 6 times 2.
Oh, for this?
Yeah.
Like, you're saying to split that up? I'm not saying that wouldn't be equivalent. It would, but we don't want to make.
Well, no, I'm just asking would it work? Like, could you down?
Would you get the same?
Yes.
Yes. Yeah. If you did the 6 times 2 there, because within the parentheses, wouldn't you have to multiply first to get 12 before you add? But is that making it simpler to do? Some of you are like trying to make this, I don't want to say difficult, you're just being very creative of how to do it, but we're trying to simplify it to
So
write
my
equivalent
original
expressions.
question was 9 plus 6 plus 6.
No, because you don't have 3 terms here. So if you did 6 plus 6, then I would be changing it to 27 plus 18 plus 18. Does that make sense? Okay. How else can I write this though? Besides 3 times the sum of 9 and 12, how else could I write that? Remember yesterday when we did this? A lot of you wanted to skip this step, and I said it was okay to skip it. I'm telling you, you're going to have to know that this is also equivalent. Some of you like going straight to this, which is fine. But you're going to also have to recognize that this is an equivalent expression. So how can I write this